solving oblique triangles. An oblique triangle is a triangle that has no right angle. The trigonometry we've done up to this point always involved right triangles. So in this very short unit, Unit 13, we are going to use the law of sine and the law of cosine to solve the 6 different parts of a triangle, 3 angles and 3 sides. And so today we're going to determine what 2 types of given information can we use to use the law of sine. So let's just quick review these. Turn to the person next to you. What does it mean to have an acute angle, an obtuse angle, and then we're going to talk about what is the range of the sine on the unit circle. So really quick, what is an acute angle? Acute angle. Less than 90 degrees. What is obtuse? Obtuse, kiddos, what is it? Bigger than 90 degrees, good. And then what is the range? Because this is the key. I provided you with this picture, and it was from a book, and we're going to use it. But ultimately, if you know the range of sine, it's going to make it a lot easier. So what is the range of the sine when we think about the unit circle? So think about really quick. Here, we have the unit circle. We know sine is like our y values. How low does it go, and how high does it go? Right, it goes as low as -1 when we include it and as high as positive 1. Anything outside that range we cannot consider. So to solve an oblique triangle, you will need to know the measure of at least one side and any 2 other parts. So to solve an oblique triangle, please write this down. Good morning. To solve an oblique triangle, you will need to know the measure of at least one side and any other 2 parts of a triangle. Now, what could those other parts be? Did I write something down here? Let's see. To solve an oblique triangle, you will need to know the measure of at least one side and any 2 other parts to a triangle. Yes. Oh, you're giving me options. Oh, I'm so sorry, Allison. One is we could know the 2 other sides. Others, if we could know the 2 angles, and maybe we're provided with 1 angle and 1 side. I'm going to press pause and give you a chance to catch up writing this. Alright, so please press pause if you're watching this back and write this down and then come back to the video. So there's 4 different cases based on the information that we're going to be provided. One is that we are going to be provided with any 2 sides and an angle. So an example, if we use this triangle that's not drawn to scale, remember that our lowercase represents the sides. Notice how they're opposite of the angle. Same letter, just in lowercase, and the capital is going to be the angle. So any 2 angles, so for instance, I could have C and I could have A, and I could have any side. So it could be like C and A, and maybe I have side A, or I have side C. It could be any side, or side B. The second one is I have 2 sides and an angle that's opposite of one of the sides. So that would be like I have 2 sides. I have side A and side B, and then I have to have an angle that's either A or B. So there has to be one that corresponds. One of the sides and one of the angles has to be the same. That's what we're going to go over today. Tomorrow we're going to go over where you have just 3 sides, so lowercase a, b, and c, or you have 2 sides and their included angle, just so we can see that. 2 sides would be like little a, little b, and their included angle is what is the angle that's created by those 2 sides. This is going to be our upcoming lesson. This is today's lesson. So again, you're going to press pause. If you're watching this back, write this down and then come back to this video. This would be the formula for law of sines. You could either write it like this, or you could write its reciprocal. It will work either way. Alright, so this is the information we're provided. We're not provided with the picture, so we need to draw a picture, but it doesn't need to be drawn to scale. So do me a favor, let's just make a triangle here. We're going to call this A, B, and C, and I'm going to put in the given information. So angle C is 102.3 degrees. Angle B is 28.7 degrees. Side B is 27.4 feet. So I know that the angles of a triangle, whether it's a right triangle or oblique triangle, always add up to 180. Let's grab our calculators and let's add this up. So I have 180, and I'm going to subtract 102.3 plus 28.7, and we can see this angle, angle A, is 49 degrees. This is 49 degrees. Okay, I'm going to put this given information in. This is 49. Angle C is 102.3, and angle B is 28.7 degrees. I'm going to press. Here we go. So now we need to figure out the two remaining sides. So a misconception of students in previous years is that we could use the old formula a squared plus b squared equals c squared. Why can we not use the Pythagorean theorem? Turn to your partner. Why not? It's not a right triangle, right? You can only use that with right triangles. So in this case, I want us to go back to what we wrote down. Can I have that piece of paper, please? Thank you so much. So we're provided with, let's look really quick. We're provided with angle B and side B. Let's look back to when we wrote down our options. Which one of these options are we given? Turn to your partner. Which one of these options are we provided with? Do we have two sides? Do we have two sides, kiddos? We do not. Do we have two angles and one of the sides? So we have AAS or ASA, however we want to think about this, right, based on this given information. And so what we're going to do is we're going to write down the one thing we know. So I'm going to write down right now, I know the sine of 28.7 degrees, okay, corresponds with little b, which is 28.7 and 27.4. Oh my goodness. We don't need to put the units of feet underneath that. All right, let's go ahead now and let's figure out what C is. So again, our angles go on top, so I have the sine of 102.3, and we don't know what little c is. Now, how do we solve this? We just cross multiply. So I'm going to take C times sine of 28.7 degrees equals sine of 102.3 times 27.4. I'm going to divide by the sine of 28.7, divide by the sine of 28.7, and this will be the side C. Just as a quick reminder with triangles, remember your largest angle directly across from that will be the longest side of the triangle. And likewise, the smallest angle will have the smallest length directly across from it. Okay, first thing I want you to do is please do me a favor, go into mode, go to degrees, change it into degrees. Next, we're going to do this together. I'm always going to put the length first. So 27.4 times the sine of 102.3, and I'm going to press enter and then divide by the sine of 28.7. Let's see if you're able to come up with the same value that I do. So I came up with 55.75. Again, what did I do? I just cross multiplied. So length C on the triangle times the sine of 28.7 and 27.4 times the sine of 102.3, and then just simple algebra here to isolate the C. I divide. The only complication students have with this sometimes is that when they're plugging it in, I choose to put this in front so that it doesn't read the sine of this times this. Sometimes that's a problem, and then I press enter and then divide by the sine of 28.7. Please practice this as we go. Okay, I'm going to come up here right away and I'm going to write this in. So 55.75, also I already know that side B is 27.4. You're going to have to write this down at the beginning of every problem. Okay, now the next thing we do is we're going to go back to what we're provided. We're provided with that the sine of 28.7 is going to represent the sine of angle B over side B is 27.4. The last thing I'm trying to figure out, 55.75, is going to be side A. So I have sine of angle A over little a, and we're going to do the exact same thing. So I'm going to take little a times the sine of 28.7 equals 27.4 times the sine of 49. How do I isolate little a? I'm going to divide by the sine of 28.7. sine of 28.7. And when I plug this in, 27.4 times the sine of 49, enter, divided by the sine of 28.7. And I come up with 43.06. So 43.06. Okay, let's come up here. 43.06. That is example number 1. Okay, as we have done previously, when you look at these options, when you get to this option, the second option for law of sines, where you're provided with two sides at an angle that is opposite of one of these. So an example, here we could go two sides. So you have side B, side A, and angle A, right? It has to be opposite of one of the sides. We have an ambiguous case. And in that situation, we're going to have one triangle, no triangle, or two triangles. Now, how do you know the situation? Let's start right now with example number 2. Please write down this given information. Let's draw a picture. We are not going to worry about it being drawn to scale. So this is A, B, and C. I know that side A is 22 inches. Side B is 12 inches. And angle A is 42 degrees. Okay, so I know I should use law of sine based on the fact of what I'm provided. I know I should use law of sine. So I'm going to get started with that right now. Let's do the sine of 42 degrees, okay, that's angle A over side A, equals the sine of B over side B. Very similar to what we did in example number 1. What is the difference? The difference right now is that we are solving for an angle versus solving for a side. So I'm going to multiply here to have 12 times the sine of 42 equals 22 times the sine of B. Remember, let's go back to sines. We know that sines have a range of -1 to +1. Anything outside of that would tell us that we do not have a triangle. How do I isolate the sine of B? I'm going to divide by 22. So that's my first step. I want to get the sine of B is equal to some quantity. So let's do the same with me, please. So let's take 12 times, by the way, let's always make sure that I am in degrees. I still am. 12 times the sine of 42. And I come up with this value, and let's divide then by 22. And this is what I have. So I have 0.36 equals the sine of B. 0.36 equals the sine of B. Okay, this is within this range. Okay, that's wonderful. So now I'm going to do second sine, because this allows us to find the angle. It's like the arc sine. And I'm typing in this previous amount of 0.36, and I'm coming up that angle B is equal to 21.10 degrees. I'm going to press pause. This is what we have so far. So this is our provided information. I've just solved for angle B, which is 21.10. Okay, let's go back to what we initially have. So let's go the sine of angle A over the length of little a equals. Now, how do we figure out this? Well, once we know angle B is 21.10, we can grab our calculator, knowing that these three interior angles of a triangle have to add up to 180. So 180 subtract 42 plus 21.10 provides us with angle C being 116.9. So angle C is 116.90. Okay, so here we go. This is our provided sine of 42. Across from it would be side A, which is 22. Then we have the sine of C, which is 116.90 divided by side. How do I solve for C here? So I'm going to cross multiply, and I don't have much room here, so I'm going to go, bless you, sine of 42 times little c equals 22 times the sine of 116.90. Isolate the c by dividing. Bless you. Make sure you show all of your work. So this is what length c is. Now when I plug this in again, I'm going to do 22 times the sine of 116.9. I'm going to get an answer. Then I'm going to divide by the sine of 42. And here's my answer, 29.32. And we can see this is in terms of inches. Let's go back and put those units in. For those that are rewatching this, I made a small mistake here in this calculation, this initial calculation. So when I figured out what angle B is, it should have been 21.41. And I can demonstrate that right now since you're not live with us. So if I go ahead here and I take the inverse sine of 36, so I'm going to do, let's see here, let me come back up here and take 12 times the sine of 42 divided by 22. I have this answer and I do inverse sine of that previous answer. You can see this is what I come up with. This is what I come up with. I did not have that down correctly. So I change this to 21.41, sorry. So when I add these up and subtract from 180, I get 116.59. I adjusted that and here's what I come up with for length C. All right, here's what we need to analyze. Is the largest angle across from the longest side? Is the smallest angle across from the smallest side? Okay, this is looking good. Let's go on to example number 3. So when I look here and I'm deciding, am I supposed to use law of sine or law of cosine? I'm provided with a side and its opposite angle and then an additional side. So I have two sides. Again, one of the angles is opposite. So this is an SSA. Remember, with SSA, we also have to be careful for ambiguous cases. So example number 2, we had one triangle. Let's look to see what we have here. So let's draw a quick triangle. A, B, and C. We have 15, 85, and 25. Okay, I'm always going to start with doing angle A, B, C. Bless you. Side A, side B, and side C. I'm going to press pause, put in what I'm. So let's go ahead and let's try to find angle B. So I'm going to do sine of 85 over side A equals, so sine of angle A over side A equals sine of B over side B. Now remember, we just did example number 1, and when I got to a certain point, I wanted to remind you that the range of A is between -1 to +1. Keep that in mind. Okay, so I'm going to multiply here. So I have sine of 85 times 25 equals 15 times the sine of B. Then I'll divide by 15. Let's figure out this on a calculator. I should move this down so everybody can see if they're rewatching this. Okay, so I have the sine of angle B. So the sine of B is equal to, I have 25, bless you, times the sine of 85. I'm going to get an answer and divide by 15. Why can I stop? Can somebody tell me why I can stop? Because the range of sines has to be between -1 to +1. Does everybody see how this is outside of that? It means it's not possible. This is a no triangle. Going on to our last. So I'm going to do the sine of angle A, 20.5, switch markers here, over side A equals sine of B over 31. 31 times the sine of 20.5 equals the sine of B times 12 divided by 12. Sine of B equals, okay, 31 times the sine of 20.5. Get an answer and divide by 12. Okay, so notice that this is in the range. This is in the range, so I'm good so far, right? It's in the range. So I'm going to do inverse sine of the previous answer. And this is what I come up with. I come up with 64.78. So angle B is approximately 64.78 degrees. But this is the sine. And the sine goes between 0 to 2 pi. So where can I find an angle of 64.78 for sines? There's two places. Sine is positive here, and sine is positive here. So one angle is 64.78. The other angle is I'm going to take 180, and I'm going to subtract this previous number to get 115.22. I'm going to draw my two triangles. Alright, so I'm going to do two different cases. This is going to be triangle 1 and triangle 2. Please no additional talk when I'm talking. Angle A, angle B, angle C. Side A, side B. Please no additional talking when I'm talking. And this, okay, over here we're going to have the second one. Make sure you're writing all of this down right now. Okay, so all of them will have angle A. So angle A is going to be 20.5. This is the given information. Side A is going to be 12. That's the given information. Side B is 31. Given. Remember, we cannot use the Pythagorean theorem. It's not a right triangle. But for one of the triangles, I will use angle B, right? That's what we just solved for here. One of the triangles, angle B, will be 115.22. The other one will be 64.78. I'm going to press pause. You know that the interior angles of a triangle add up to 180, so you can quickly find out angle C and use law of cosine to find side C. Same thing, add up these, subtract from 180, and then you can find side C using law of cosine. I would like you to see, can you go ahead on your own and figure these out? Ready, get set, and begin. Okay, so this is 94.72. 94.72. 180 subtract 20.5 plus 115.22. This is 44.28. Okay, so I'm going to do law, real quick, I'm going to do law of sines with this one. Okay, we're going to use what we're given. So we are given A. Use the given. So I'm going to have the sine of angle A over side A equals, and over here I'll do the same thing. Okay, and I'm going to do over the sine of angle C, 44.28, over side C. Sine of angle C over side C. And now we're just going to cross multiply to solve. So please make sure you are showing all of your work. I'm going to walk around. All of this must be solved on your paper. Do not get lazy. We can ask our calc kids in back. Does Mr. McFarland allow you to skip any step when you're showing your work? No, not even one little step. And then you get back a 0 for that part of the homework, right, on that question? He is very, very detailed with every adding and every subtracting of everything. So please get used to it right now. Okay, so I have 12 times the sine of 44.28. I'm going to get an answer and divide by the sine of 20.5. All right, and I come up with 23.92. 23.92. I'm going to do the exact same thing over here. I have C times the sine of 20.5 equals 12 times the sine of 94.72. Divide by the sine of 20.5. Divide by the sine of 20.5. Okay. 12 times the sine of 94.72. Now divided by the sine of 20.5. And we have 34.15. 34.15. Let's make sure that the largest angle has the longest side, smallest angle has the smallest side, same thing, largest angle, longest side, and smallest angle, smallest side.